So now let us look at a possibility, that is Roman numeral 2, without replacement, where every time you pick a ball out of the bag, you don't replace it. So we shall have a bag as usual. Remember, this is without replacement. So we have a bag. Now our bag is still having 2 red and 3 green. So I'm going to pick. Remember, in this case where I don't replace, when I pick any ball, I throw it away. I don't put it back into the bag. So I'm picking for the first time. I can either pick red, which is probability is 2 out of 5, or I can pick green. Sorry for that. Let me rub it off. So, or I can pick green, which is probability of green, which becomes 3 out of 5. So I have picked for the first time. Remember, I'm picking 2 balls. So if I'm to pick again for the second ball, remember it is without replacement. That means that the red ball here that I picked is thrown away. So that means that the bag is having now new content, which means if I picked a red ball, now how many, and I've thrown it away, how many red balls are remaining in the bag? It means now the red balls it is only 1 red ball. But remember, with picking red, I did not do anything on green. That means greens are still 3. You see that? When I pick red and I throw it away, I don't replace it. Our reds become 1 from 2, and the 3 and the greens are not affected because for the first picking I picked red. Now for the second picking, where I picked green, red is not going to be affected because I've not picked red. That means red is still 2 red. What about green? Now green has reduced because I picked green here and I threw it away. So that means green is still 2, becomes 2G. Take note of that, with and without replacement. For the first case, it was with replacement. That means every single pick would replace it to the bag. So the sample space was not changing. However, here, you realize that when I pick red at the bag and I don't replace red, means that the bag is now having 1 red less, which becomes 1 red. But in case I picked red, green is not affected. That's why green is maintained here. See that? Then, in case I pick green, red is not affected, but green reduces by 1. So I pick again because I'm picking 2 balls. There are 2 possibilities again. I can pick probability of red. Sorry for that. Probability of red, which is equal to 1 out of 4. Probability of red there is 1 out of 4 because the sample space now is 4. 1 out of 4. Or I can pick green, which becomes probability of green, and it is equal to 3 out of 4. Or in case I picked green at the first time, what is this possibility here? It can be probability of red. In case I pick red, will be 2 out of the sample space is 4. Or in case I pick green here, probability will be still 2 out of 4. And that will be the tree diagram. But remember, I still want probability that the balls that I picked or that I've picked are of the same color. So it means that they want you to pick red for the first time and red for the second time. Or you pick green for the first time and pick green for the second time. So we are going to consider this and this, then this and this. It cannot be this and this because this one here you picked red, for the second time you picked green, and they are not of the same color. So it is red and red, or green and green. So we therefore want probability of red 1 and second time red, or which is plus probability of, sorry for that, I'm trying to find out. Sorry for that. So it is the probability of green 1 intersection green 2. This one will be probability will be equal to probability for the first red is 2 out of 5 times, this is 5, times 1 out of 4 plus 3 out of 5 times 2 out of 4. When you simplify that, you end up getting 3 out of 5 as the answer.